have my consent for that?
You're not on the video.
Well, then you have my
And you do have my, I do have your consent because your parents had to opt you in.
Wow, that is.
Or opt you out.
We're to level 8
I'll call my
All right.
on the
Let's see here. Who all are we missing?
Look how HD this
Macy
is.
and Jessica. Macy's
I
looking
don't
good.
know. Oh, wait.
That probably is it.
That is a good one.
All right.
Probably one of those excellent.
Moving forward. Hey, Ken, why don't you go sit down? Thank you.
I didn't take it. She's bold.
All right.
Dude, I used to take it back.
Moving forward in Trig.
Wait a minute. I'm reading.
In Trig, we have been learning about these nifty functions. These nifty functions like trig, like sine and cosine and tangent, that we can solve all kinds of authentic problems with. And we can actually learn how to figure out how to... Hey, we're not going to do that anymore, okay? And so... Anyway, why don't you slide over a little bit? Yeah. All right. And so the next one is moving up to the next row, so be happy with that one, okay? All right, so we've been learning about these useful functions like sine and cosine and tangent and so on. And now we're going to be doing more of the things we've been doing with functions since literally the beginning of August. Well, actually, some of the things that we've been doing so far have been the same things we've been doing since the beginning of August. I mean, think about it. We've already been doing things like talking about the parent function, and we've been doing things like transforming the functions with things like shifting it and changing its period and finding its x-intercepts and y-intercepts and all that kind of good stuff that we've been doing at a, well, look at that, a graphing approach to these kinds of functions all along. Well, another thing that we've been doing with these functions since literally like August has been talking about their inverse functions. Whether we were doing simple algebra type functions, you know, things like f of x equals 3x plus 1, or whether we were going for more for bigger functions that were like polynomials and stuff, or whether we really swung for the fences and we're doing things like the log and exponential functions, like f of x equals the natural log of x. Many times along the way, finding the inverse function has been part of what we were doing. Remember, the inverse function was that nifty thing about where we could undo what the original function did. We learned this back in literally like third grade, literally like late August. About like how composite functions, how we could like talk about the, you know, like if f and g were inverse functions of each other, f of g of x was just x, because whatever the first function did, the other function undid. Like if f of x was add 3 and g of x is subtract 3, one just undoes the effect of the other. F of g of x just undid the first one, or divide and multiply. If f of x is multiplied by 3 and g of x is divided by 3, they just undo each other. You just get back to x when you're done with them. We took a much bigger leap of faith. Oh, by the way, at that time we also did the whole set of steps on how to just compute an inverse function. You know, but we didn't. That was a long time ago. Then back by about November or so, when we were hitting these log and exponential functions like natural log and log, which I totally understand that you have already forgotten the functions themselves. For the moment, that's okay. But what did you say?
For the moment.
Yeah, for the moment. We'll come back, there'll be meetings about that. But for now, it's okay. But we also, at that time, were learning about how log and exponential functions were inverses of each other. So the inverse of natural log was, the inverse function of it was e to the x. E to the x, the exponential of, you take that number, e, 2.718, whatever, and raise it to x, that is the inverse function of log. We had, for example, the common log, like let's just use g of x, was the common log, the log base 10 of x. Well, then the inverse function of it was 10 to the x. And we beat this to death in like November. And the reason why these were useful is it was a way of cracking certain kinds of problems. If we had a problem like the natural log of x equals 2, algebra fails you. There is no way to get that 2 out of there using anything you learned in Mrs. Webster's class. No FOIL, no factoring, no rearranging terms, no whatever is going to get that natural log of the natural log of x. But if we just do the same thing to both sides, in this case, take both sides, e to the, whatever you have, that's fair. They're just doing the same thing to both sides. E to the power of, and the natural log of are inverses of each other, and they undid each other. They cancel out. Just like plus 3 cancels out negative 3, just like divided by 3 cancels out multiplied by 3, e to the natural log of canceled out and just left the x over here, and you get e squared on that side. That's just a number. E is just 2.7 whatever. Square it, you've got the answer. This business of inverse functions was primarily useful to us in pre-calc because it helps us bust things out, turn variables out of the inside of like a log or an exponential. And we're about to start hitting problems like that in trig too, where we've got a variable inside some kind of function. We're going to have problems that look like this, like sine of x equals 1/2. Nothing, these are transcendental functions, to use the right term from like a math theory class. These are transcendental functions. Literally nothing you learn in algebra can solve this problem for you. There's no factoring, there's no quadratic equation, there's nothing you've learned that was going to help solve this. What we need is some kind of way to get the x out of here, so there's not sine of x anymore, and then there's just numbers over here. What we need is a function that is the inverse of sine. What should we do? What?
We call that function inverse.
We do call it either inverse sine or arc sine. Let's use the symbol inverse sine though, because it's going to match our ideas. If we had another function here that was the inverse of it, and for now let's just call it inverse sine, because you have a button labeled that on your calculator. I don't know what the hell an inverse sine is going to be just yet. Well, I do, but you don't. I don't know what that is. But whatever it is, inverse sine is going to cancel out sine and just leave the x behind. Of course, I got to do the same damn thing to the other side too. Whatever inverse sine is, we got to do it on both sides. But this makes good sense. This is a good plan because inverse sine, whatever the hell that's going to turn out to be, is going to be able to cancel out sine, and we just get x. And then over here we have inverse sine of 1/2. I don't know exactly yet what that means. I'm going to have to decide what that means. But for now, I don't know damn good one when I pull out my calculator if there's an inverse sine button.
So as long as we get x by itself.
Yeah, that's what solve means, right? Solve means come up with a number that you plug in for that variable, right? So by getting rid of that sign, we now have x equals, and this is going to be something I can put up in a calculator. Well, actually, in words, what I want for inverse sine isn't all that hard. I mean, if sine meant like sine of x equals y, you know, there was some value of x, and we put it in a calculator, and we sine of x, and we get y. Kind of in words, it's not that hard to think through. It just means that the inverse sine of y should be equal to x. They should undo each other. In words, x is some angle. Maybe x is a better choice. How about we use theta instead? That might make you happy. That might make you happy because we often think of theta as angle. That might make you happier. I have some angle theta, and one of the things we can do is compute the sine of that angle. You can always do that. We'll call that number y. The arc sine, or inverse sine of y, is just the opposite. I know what the value is, the y I'm pointing at. What's the angle it took to do that? The inverse sine means what is the angle that this would be the sine of it. Let's do a simple one. How about the one we did over here? We had this problem that the answer was x is the inverse sine of 1/2. In other words, we want to know what angle x is the angle that its sine is 1/2. See how in words that's actually not hard to think about? I just mean, what is the angle I'm pointing at? What is that angle I'm doing that its sine is 1/2? Well, actually, we could go look at that diagram in the front of your book, which conveniently already, right there in the front cover of your book, you got that unit circle. Remember, every one of those little angles on there, it's got that pair of points, that pair of numbers. The first number is the cosine, and the second number is the sine. All we got to do is find the one that points to where the sine is 1/2. And it's at pi over 6. So, x equals pi over 6.
So all we're doing is we're looking for the y value.
Well, you're trying to find the value. Okay, you're finding the angle that pointed so that the sine was pi over 6. Now, it gets a little more complicated. If you look a little closer around the circle, you're going to find that there was one other place too.
Pi over
Because
30.
it's not, what?
Talking about pi over 30.
5 pi over 6.
I was thinking 5 pi over 6.
Oh, why is it not this one then? Is that this one?
Because, yeah, but that's the cosine value.
Oh, yeah.
Yeah, we're doing sine. Yeah, good. Let's see how this works. The inverse cosine, or the inverse sine rather, we just mean what is the angle that gives us this as its sine. It undoes the idea of sine.
Thought it had to be an inverse of 1.
What?
Thought it had to be an inverse of 1.
The inverse sine of 1/2.
Oh, okay.
Yeah, that's pronounced inverse sine or arc sine for complicated reasons. Inverse sine or arc sine. Your book actually has like a paragraph that explains why it's sometimes called arc sine, but I was like, I've done math for a zillion years and I don't understand that.
So do we just plug in the two values of that y and then whichever one's closer to the number we need?
Yeah, well, what we want to do, good point. See, Canon is saying, wait a minute, how do I know which one of the ones to use? This idea of an arc sine or an inverse sine. In other words, which ones are in its domain? I mean, if this is going to be some dumb function, it must have some domain. And that actually gets to be a complicated issue. See, here's the deal. Let's actually make ourselves, we learned a nifty graphing trick way back in August about inverse functions. To be any kind of function, they had to pass the vertical line test. No sweat. But to be a function that has an inverse, they had to have pass a horizontal line test too. In fact, hold on just a second, I'm going to check something. I'm not making a mistake. Yeah. Okay. See, if I actually made the graph of this guy, here's the graph of sine. Oh, I didn't quite do it right. Close enough. You get the idea. Let me fix it a little bit. You got a little bit out of control there. All right, he looks something like that. Does this guy pass a horizontal line test? No, he's kind of the definition of what doesn't pass a horizontal line test. Because any place I draw a vertical line, I'm crossing it lots of times.
You mean
So, but the game here is we're going to say, yeah, but from here to here, we're good. The graph of sine of x does pass a vertical line test, a horizontal line test between negative pi over 2 and pi over 2. This range, or negative 90 degrees to 90 degrees, in that range it does pass. So it's okay to talk about the inverse function of sine, as long as we're only talking in the range from negative 90 to positive 90, or from negative pi over 2 to pi over 2. Then we can do the nifty graphic thing where the inverse function should be just like the reflection of it across a 45-degree angle. Remember that trick? We draw a 45-degree angle in here. and it'll just be the reflection of that. Anyway, so inverse sine of x. The x is going to have to be between -1 and 1. The x, the domain, if you will, of inverse sine is going to be from -1 to 1. Which makes sense, right? I mean, what would the inverse sine of 4 be? Inverse sine of 4 means the angle you point to whose sine is 4. Does any angle have a sine of 4? No, sine goes from -1 to 1, right? So 4 isn't in the domain we can use for inverse sine. It's not an angle, there is no angle that points to a sine of 4. And it's going to have a range of results from -pi/2 to pi/2. Or -90 degrees from -90 degrees to 90 degrees. And we all have calculators. Yours in, what you got, an app or something, don't you? Yeah, I got a calculator app. I do too. Let me get out my calculator app right here. And most of the time, calculator apps, of course, if you turn the horizontal way, you get the scientific calculator mode. And you got to look to see if you're in degrees or radians, which makes sense, right? I mean, it's going to change your answer. I will put mine in degrees, just because it's a little easier to think about degrees sometimes. All right, so the problem we had been wondering about was the inverse sine of a half. I've got a little button on mine that says inverse. Inverse, and then actually it has the little -1 symbols over here, so now it becomes it's inverse sine, sine of -1, but your results, your mileage may vary. You may have a different looking button on yours. But inverse sine of 1/2, and I hit equals, I get 30 degrees.
But my inverse sine would be the signage.
No, that's hyperbolic sine, which is another whole thing. Did you just say what I think you did? Inverse sine, you have a button, what is second? Yours is second, and it's, when you do that, it's the -1s after everything?
Yo,
Yep.
that's crazy.
Second is another possibility on your calculator. Okay?
I did not know that.
I will gladly help anybody who cannot find it on their calculator. On your calculator. You got the second button right there. So second, when you put the, push the second button, see how it puts the -1s right next to everything? Yep.
I wish I knew that.
Second is a good one. Sometimes it's inverse on your calculator. Yeah, you got it. You show yours? That's, yep, inverse. And then when you push that, watch what happens. See all your functions now have the little inverse symbol on them? Yeah. Perfect. Okay, so the inverse sine, and then just put in like 1/2. Inverse sine of 1/2, if you're in degrees mode, you're going to get 30 degrees. If you're in radians mode, you're going to get pi/6. But remember, then that is the angle in the range from -90 to 90, or from -pi/2 to pi/2, where that is the angle that points to a sine of 1/2. We're just generalizing this idea of inverse functions. We did it for algebra, we did it for logs and exponentials, now we're doing it for trig. Yeah. Yep, we're not going to ever get answers that are there then. When you put in, when you put in the inverse sine of whatever, it's only going to return an angle from -pi/2 to pi/2. The answer will always come back in that range. Yes. Yep. So we're on. Now, it would be super nifty great if we could then say, and the same thing works for cosine, and there's an inverse cosine, and there's an inverse cosine. And if the same thing worked for trig, or for tangent, and we could say there is an inverse tangent, and there is an inverse tangent. And they all work kind of the same way. Let's try this one. How about the cosine of x equals 0? That is a perfectly reasonable problem to have in a trig class. What is the value of x here that makes the cosine of x? Heck, let's even make it, I like theta better. Let's use theta. The cosine of theta, what is the angle theta that makes its cosine is 0? Sounds perfectly reasonable. Again, solve for theta here, algebra fails you. There's no way from Mrs. Webster's class you could actually get the answer to this. But if we had something called the inverse cosine function, and we just did it to both sides, again, not really sure what the heck inverse cosine is yet. But inverse cosine and cosine would cancel out. That's what inverse functions are. They cancel each other. They undo the effect of the other one. So the inverse cosine of the cosine of just returns you the original thing, theta. It's the only way we can bust that theta out of the cosine. Yeah.
So, since sine and cosine are the opposites of each other for angle measures, would they always equal like 90 or 180 or something?
No, that would say that they're opposite of each other, but they do play kind of opposite roles, right? One is sort of the x coordinate, the other one's the y.
Right.
Yeah.
Recline, I'm trying to-
I'm not sure I'd like to answer that question though about would that same be true for the inverse cosines and stuff. You'll see why in just a minute. Okay? Alright, so this would just be a thing. We would just need the inverse cosine of 0. In other words, we need to know the angle that has a cosine of 0. And once again, one possibility would be to just flip to your front of your book and look at your unit circle and find the angle whose cosine, which is that first number of the ordered pairs, is 0.
3 pi over 2?
That is one of them.
Is it 2 pi?
No,
Is it 90 degrees?
it's like 90 degrees. But I also like Aaron's idea that 270 degrees, or 3 pi over 2, also works. I mean,
Shout out, guys.
okay, so like 90 degrees, I'm gonna write 90 or 270, or pi over 2, or 3 pi over 2. Okay, they both look right. Looking at that unit circle, they both look right. Which one to take? Well, all right.
The one that's easier?
No, well, frankly, I don't care. Yeah, no, I'm just kidding. Here. Let's make a graph of cosine. Cosine looks like this. Cosine looks like this one. Is it a function? Is cosine a function? Sure, it passes the vertical line test. Does the cosine function that I just drew up there, does it pass a horizontal line test? No way. Nope, no chance. Every place I draw a line, it crosses lots of places. But we could play a little game. Well, before we were doing it from pi over 2 to from negative pi over 2 to pi over 2, but we still would have problems, right? We'd still be crossing twice. And your book says, well, what about if we did from 0 to pi? From 0 to pi, our function is passing a horizontal line test. It does have an inverse. We'll call it inverse cosine, and we're happy. And we could do all the nifty things of like figuring out what that, do the thing where we flip it across a 45-degree angle to see what the graph of it looks like. But inverse cosine then only works from 0 to pi. That's the only thing that's in its range. It again only has a domain from negative 1 to 1. What would be the inverse cosine of 4? That would be the angle where it points to a cosine of 4. Does anything point to a cosine of 4? No, they only go from negative 1 to 1. So everything about inverse cosine works just like it works with inverse sine, except for we have a different domain over which we can do it. Sine goes from negative pi to pi, negative pi over 2 to pi over 2, and cosine, inverse cosine, or arc cosine goes from 0 to pi, and I hate that. That's why a good friend in this activity today is on page 317. Always the trick is blue box with yellow highlighting. The blue box with yellow highlighting, make sure you know what are values you can use for the domain and what values you can use for the range of these functions. But other than that, they're pretty much the same thing. your book is going to spend a lot of time throwing problems at you. Things like sine of 2x equals 0. They're going to want you to solve equations that use these things. And we're only going to kind of nibble at this a little bit in this section, because the guy who wrote the book totally gets it, that this is just, we're really beginning, this inverse function thing isn't something you really saw since like Christmas. Let's take a little break here. But, to bust this thing out of sine, there's really only going to be one thing we can do. We know that we have to take the inverse sine of both sides. Taking the inverse sine of a sine cancels out. So far, so good. Inverse sine of cancels out and just leaves the inside part. Inverse sine of 0. You could do it on your calculator. You could do it using the diagram in the front of the book by looking for what angle points to something where a sine was 0. It looks like the sine of 0 happens at 0. Sine of 0, inverse sine of 0 is 0. So then what's x? Apparently x is equal to 0 here. They're going to throw some problems like that at you. But then they do something hateful. And I'm not terribly happy about it. And I need to do more checking as to how big of a deal to make about that. For example, they start doing things like, what is the sine of the inverse cosine of 1? Do those two cancel out? No. One's an inverse function and one's a regular function, but they don't match up. Right? One's a cosine and one's a sine. Now, at this point in the game, all they want you to do is kind of reason this guy out. For example, start with the part inside. Inverse cosine of 1. That would be the angle who's pointing at a sine of 1. We go look over here. Looks like it's 90 degrees or pi over 2. So this stuff on the inside is just pi over 2. Well, then it wants to know what's the sine of pi over 2. Well, again, from your calculator or from the figure in the front of the book, you can find pi over 2 and find its sine, and it's equal to 1. So inverse sine of sine of inverse cosine of 1 happens to be equal to 1.
Wow.
Oh, is that right? No, that can't be right. Cosine, I did this wrong. The inverse cosine of this is 0, isn't it? Hold on, inverse cosine, yeah. This is 0. Inverse cosine, that is the angle whose cosine is 1. Then the sine of 0, which happens to be 0. Yeah, so this whole thing evaluates to 0.
So is it either going to be like 0 or 1?
No, I'm just picking an easy one to do it there. Yeah. You could do this using your calculator. You could use these using the unit circle in front. But they get a little ugly. And hateful, I dare say. Let me give an example here. I really dislike, on page 321, I would be willing to start a fan club for hating problem, example 7, number A, which is asking the tangent of the inverse cosine. They actually wrote arc cosine, but they mean the same thing, of 2/3. That's evil. They did something bad to you here. Again, there's a cosine, there's a function and there's an inverse function. It doesn't look like it should be so bad until you realize they don't match up. One's a tangent, one's a cosine. Alright. Also, 2/3 isn't one you could just find on the unit circle. If you flip to the unit circle in the front of the book, it seems like inverse cosine of 2/3 means find the one that points at 2/3, but it isn't one of the ones on the unit circle. It's not a nifty, nice thing. Could you do this with your calculator? Hell yes, you could do this on your calculator. You certainly could go into your calculator and compute the inverse cosine of 2/3, which is going to be some number that happens to be the angle whose cosine is 2/3. It's going to be a weird number. And then you can take the tangent of that number and you get another weird number. And it would be digits. As long as you showed me your work on paper, I really wouldn't care. The book says, you know what, let's think about this a little bit. The book says, whatever angle this is, I mean, this is the angle who's got a cosine of 2/3. In other words, there's some angle out there where the cosine of 2/3. Cosine is adjacent over hypotenuse. So the adjacent side of that triangle is 2, and the hypotenuse side is 3. Hell, we could just use Pythagorean theorem. It works out to square root of 5, if I'm not mistaken. Hold on. This square? Maybe not. Hold on. Yeah, square root of 5 for this side. So this is the angle. He's got this side is 2, this side is 3, this side is square root of 5. Let's see, tangent is opposite over adjacent. So this whole thing is 2 over square root of 5. And you're done. Or you could be happier about it and say 2 square root of 5 over 5, because math textbooks like that. Hateful! Hateful problem. I wouldn't assign those problems to Canon.
Don't let your unequal things.
What?
It says the square root of 5 over 2.
Square root of 5 over 2?
Yeah.
I'll tell you upside down.
Square root of 5.
Opposite over adjacent?
We wouldn't have a bridging.
Oh, yeah, I got it upside down, you're right. Opposite over adjacent is square root of 5 over 2. Oh, you know, you're right. I probably shouldn't be doing any construction. Yeah, I won't be finding any bridges anytime soon. Alright, if you have problems like that, can you just use your calculator? Yeah, I'm okay with that. I don't love it, but you can do it. It'd be better if you worked it through the way the book did. But at this point, I'm unwilling to have that battle because here's the deal. I haven't yet seen, I don't plan on asking you awful ones where they're like that. Where they're mixed, where there's like a tangent and a inverse cosine, or a sine and an inverse cosine. I would ask you ones where they pair up like this, but these ones where they mix, I know later in Trig we're never going to see that. So why are they being mean about it? Yeah, Harry.
So something like that would not be on the test.
I don't intend to put you any on there. But here's the deal. I have not yet seen the final at the end of the semester from downtown. I am a little spooked that this matters more to them than it does to me. Okay? So until I hear back from a note from them that I've written that says, so really, is that a big deal? Or is that like,
minuscule.
you know what I'm saying? There's things you hit that, like, that's kind of beyond. That's not actually going to be like one of the goals of class that gets measured at the end of the semester. I'm inclined to say, if you solve one thing like this with calculus, with your calculator, if you are smart enough with your calculator and experienced enough with your calculator, you can solve these and get the numbers on the calculator, and it's the right answer. You're going to look in the back of the book then, and they're going to have said something like square root of 5 over 2, which your calculator isn't going to have given you, right? It's going to have given you a bunch of digits. But check it. Check to see, square root of 5 over 2, is that the same as the digits you got? Honestly, that level of sophistication with your calculator makes me more than happy. Okay, we're still running over there. Yeah, I'm good. I was worried I was going to run out of battery. So, if you come across ones like this, and I think there are a few of them, where they're mismatched like this, calculator is fine. Okay? If they aren't mismatched, like they're more like this, and you got to understand what inverse functions are for and all that kind of stuff, then I'm happy. I mean, then I want you to do it. All right. This is kind of a big leap here. This business of taking what's kind of been a theme the whole semester, discovering different kinds of functions, polynomials, rational functions, whatever, and then doing things to them. We shifted, we reflected, whatever. We described them in terms of things like their intercepts and their local maxima and their local minima and the end behavior. Remember the ones that went up at the end of the one. Here we are doing another one of those things that was always along the way, which was their inverse. For what it's worth, this is the last step on that. It isn't like come around March, I'm going to tell you there's even more functions. So we get to do even more things like describe them in terms of shifting and reflecting and their y-intercepts and their x-intercepts and their local maxima, and then tell you they have to find their inverses. We don't go any, this is the end of that path that we've been on since like August. Okay? Well, what we're going to be using these things, but we're no longer discovering them. All right, so what are we doing for today on homework? Today's homework is on page 322. And it is problems 1 through 13 odd. It is problems 19 to 31 odd. And then, let's say 45 and 47. I had more problems, but I want to throw those out. I'm just going to highlight those. Not that it was huge, I only threw out like 5 problems, but you know what? That's enough. All right, yeah, Ryan.
So, did you say that there's, so, both these equal the same thing. Did you say that there's a way of finding, like, square root of 5 or using a
Just use your
calculator?
calculator, yeah. Not necessarily decimals, because I don't know.
Regular calculator will pull up with square root of 5.
Yeah, yeah, let's do that. Yeah, you can see answers what's in the back of the book.
Can you find arctan?
Yes, I sure can. Okay, so you got the same one coming.
Yeah,
So second, notice how when you switch to
Where does
second,
it teach
you
me?
made you a crane. Don't be disruptive. Brendan has to be focused. Okay, right. So when you touch that second button, notice that a lot of the functions change. And the main one that was Roberta pointed out is notice how it's changed the inverse sign. So like inverse
It's just
sign.
the stepping stone on the thing.
I'm sorry.
What? On the
0.5 inverse sign.
It's the stepping.
Okay, 0.5 inverse sign should have given us either 30 degrees or pi over 6
So
degrees.
if y is pi over 6,
Pi is right around 3, 3 divided by 6, right around half, that'd be about right.
kind of
Oh,
walks
we gotta switch ourselves over to
chart.
degrees mode. How does your
So, regular square root of 3, that means something pi over 6.
Let's try it again. 0.5 inverse sign.
What page?
Alright, so
you have to put like the
Which chart? The box is
Because I was like,
yellow
doing it at
highlighted.
first, I was like, I'm just
Yeah.
gonna 0.1.
so apparently your calculator wants it the
if
other way around.
pi over
Okay.
6 is
Number.
going to do
Oh, I don't know. Everybody's calculator's different.
Pi over 6.
You
Where
know,
do you
we
see
are-
pi over 6?
I said before.
Oh, that
Here
chart.
is what
You
goes
said blue box yellow highlighted. I said above is wrong. Oh, I didn't hear you say above.
You know what I'm saying? If you were
But
all
like if that's
using
pi over 6,
Android calculator to mobile iOS
I mean,
or
we already used Desmos.
does that mean
Why don't we use
that
Desmos?
square root of 3 would be something wrong with pi over 6?
why not support it that much?
Yeah.
No,
So
it's like
that
saying
we're all on the
that's
same
the-
page. That would make things
That's
better.
just the
I
cosine.
mean, don't get me wrong, there is a teaching value too to,
What
it
hypotenuse?
doesn't matter what the calculator is.
That I don't know. I don't
Yeah,
know
so
what
what
is
is
it,
it?
sine or cosine, but
Yeah, exactly.
Science X, right?
And so, it's just that it would kind of be, from a teaching point of view, kind of better if everybody had.
Yeah.
And so, just trust me, it comes at night, because I get that beep on my phone with somebody working on homework.
Stroggy?
I love it.
Stroggy.
That's why I give you that.
That's why I don't text you, because it's not like creative.
Okay, don't do your homework at 3 a.m. And so, but anyway, it would be helpful, like it's, you know, we were all using the same calculator for things like that. Somebody had a question over here. Yes.
because you didn't go over tangent or.
Tangent's fine, they work the same way. So arctangent works the same way.
As
It is
1. Same way as 1.
Inverse sine and inverse cosine.
But it's not x or y.
Yeah.
Thank you very much.
It's the hypotenuse value.
Yeah, so if, okay, let's talk about tangent.
Hold on, I just like,
So like, what do you
He's
want me to do?
So
If
again,
I put it on the other side, I don't get anything.
so like if you had a problem, the tangent of theta equals 1. You want to know the value, you're talking about the angle whose tangent is 1.
Yeah.
Now, I
That's
guess
all
we
of
could, what?
That's all of them.
No, no,
Is it
just-
not because it's the hypotenuse value.
No, tangent is sine over cosine,
Yeah.
okay? So, I mean, any number of angles have some value of their sine and some value of their cosine. I don't know that one. So that's not going to be 1.
X over y or y over.
So here's the deal. The particular unit circle they gave you here, you probably would have been happier if they had then put, like, see that's cosine and that's sine. They probably should give you tangent.
So cosine's that.
Cosine is the x coordinate, the y coordinate, and tangent is the ratio.
So if I do arctangent, so I have arctangent square root of 3. So that would be
So-
tangent of 0.
So square root of 3.
Sine have tangent. Oh, I get it. Okay. Tangent of x equals square root.
Inverse tangent. Let's do that one.
I got it. So what if I just plug in? I can't just plug in. Tangent to any number.
Does it actually say without using a calculator on that one?
Yes.
So that's inverse tangent
They all
of square
three,
root.
first three say that.
Alright. I wrote those problems like in October. I don't remember why I said without calculator. Let's see about that one for a minute. Okay, so the arctangent or the inverse tangent of square root of 3. So you are talking about
Equals x.
equals.
Because that's what we're trying to find, is what value makes that true.
Yeah, okay.
Otherwise, you just have the numbers, and that's
Yeah,
it.
just numbers. Yeah.
And then
All
you can't compare
right.
this.
So this is the angle theta
Yep.
such that the tangent of theta equals square root of 3. Okay, so we're looking for an angle whose theta and, I'm sorry, so sine of theta divided by cosine of theta equals square root of 3. Well, for one thing, we could just go and try. You've got 4 options there, right? It's a multiple choice one? Okay, so we could go over here and look at your unit circle and say, which one could it be? And you would have like pi over 6 and you have pi over 2. You could try, you're trying to find ones though that you have the 2, so that the ratio of sine and cosine is going to be square root of 3. But here's the deal, when I actually look at the unit circle, only one of them has square roots of 3 in it. The pi over 6 ones. So if I was doing this just using the unit circle, I would say, look, at pi over 6, I mean the sine of pi over 6 is equal to square root of 3 over 2. And the cosine of pi over 6 was 1/2. Is square root of 3 over 2 divided by 1/2 multiplied by 1 side by 2? Yeah, that's equal to square root of 3. So the only one that had square roots of 3 in it was pi over 6.
Okay.
So that's probably the answer, right? But I said without using a calculator. I don't know why I wrote those. I wrote these exit tickets
The
in
other two
October.
I got. The other two make sense.
Yeah. Or you could just use, frankly, on the first day we're doing these things, it says don't use a calculator. But frankly, if you want to use a calculator, use a calculator. We could also put in your calculator inverse tangent of square root of 3, and then figure out you're going to get digits, and then figure out which of those digits matches which answer, right? So you got some digits. Is that pi over 6? Is that pi over 4? Is that negative pi over 4? Whatever all your options are.
I just get the degree measure.
Or the degree. Yeah.
But I guess that gives you the answer.
Yeah. That's what I'm saying. Or you could just.
Alternative
I
notation.
finished
Where do we say that here? Oh, alternative. Okay, so they're just making a deal about the fact that tangent, like writing it like this with this inverse symbol here. So arc tangent is the same thing as inverse tangent. Or arc sine is the same thing as sine inverse. That's what they mean. Right? When they say alternative notation, they just mean which is the other one. The reason why they do that is because you see those two notations about equally off common. Okay, like in a problem. And so they want to make sure you know both. Yeah, let's take it. Okay. So that would be, yep, cool. All right, good. Yep. I'm happy. All right.
Yeah, dude, that's like me.
Oh boy, oh boy, oh boy. Can't wait to do 2
Yes, sir.
Are you raising your hand?
Oh, okay. I thought you were. Did you ever get your stuff sorted out with the teacher out at?
Yeah, I know it's in that same letter.
And it was all good?
Yeah, he went over the quarter of me and
Okay. I mean, as long as
He wants a packet to my favorite teacher.
I hadn't noticed. I actually had one of those stoplight kind of things, you know, radars or whatever, about shit. I hadn't noticed that it was, you know, that color. You know, so.
Like every
I mean, the first couple weeks,
this semester.
it wasn't pretty great, right? Yeah, you know what I'm saying? It's, I don't get too fussy about those kind
Well,
of
he's
things.
real strict about the attendance. The other teacher wasn't. He said that I need to be on an hour a day. He checked the attendance every day.
Okay, good. Well, I mean, I have not met him yet, but they have like a profile of him on the teacher's website.
Just by
And
alternative notation.
it means the other way around, whichever you called it. So like if it's called arc sign,
Yeah.
they do the sign inverse.
And then they, what if they just ask the location for the first time?
Where were you on here?
Well, we actually.
So this one's the alternative notation.
Number 3.
What notation do you
Except right now.
use to represent the inverse? So arc sign and sign inverse, yeah.
Mr. Trig,
Yeah.
I'm asking for a friend. Is that's the same thing, right?
Yep, that's what they mean. When they say alternative notation, it's just that these are both, it is the kind of thing where there's one way that's always used and the one, they're both kind of,
Yeah.
I forgot how these are.
So
Two ways to
whenever
say it.
arc is in front of whatever, just.
That means like.
I don't know.
Yeah.
Like, I don't know.
What is he? What is he?
What do you mean?
Like, whenever the arc
And
is
sign
zero,
is
like,
inverse sign.
that's all I
So
can
arc
do.
sign, so no, so arc
And then
sign
the rest is
zero.
scraps.
Same thing as like, would mean the same thing as inverse sign of zero. It means what angle points have a sign of
See you.
zero. So like if we looked at our unit circle there, we could just scan from the book there.
Oh.
What angle, so remember that's little,
So just put it in
where it
the
has little
calculator?
points on here? That's what they are. So the first one is
I
cosine,
can
the
see
second one
that.
is sine.
That's
So which
what
one has
Put
a
it into the
sine of
calculator.
zero? It looks like it's at zero,
you know,
right?
You know?
At the angle zero,
I'll design a program
has-
in Python to make it cool. And just not call it
the sine of it is zero.
Not
Not
no.
calculator.
Make it
So that's zero. Zero, the angle of zero
not using
has a sine of zero.
Yeah, okay.
Okay, all the other ones have a different sign.
Yeah, I gotta do the exit ticket.
Yes, I emailed it to you. Yeah, because my server's down here, so it was the power must have flickered at the house or something.
So do I just write the answer?
Wait.
You just want me to like.
Okay. Yep, because that is the arc sine of zero means what angle has a sine of zero. And happens is the angle of zero.
Yeah,
Arc
see.
sine of zero.
Yeah.
Arc cosine of
Yes, but it's outside of the range.
And the other one
It's
is
range rather. So we're only going to do sine. So 5/2, 5/2.
I'll show you.
arc sine and negative.
So that one's outside the range. Yeah, that one was what we were doing over here. Okay, so we're looking for an angle theta, so that the tangent of theta is square root of 3. And tangent is sine over cosine. So we can sit there and look through on our unit circle. Where did we have something where we had this, those two coordinates in there? Where if we put the sine one on top of the cosine one, we'll get square root of 3.
Yes, sir.
And with a little experimentation, we found it's pi over 6. Because that is square root of 3 over 2 divided by 1/2.
Number one is here.
Because that's the sine and that's the cosine.
So 30 is.
Or you could use your calculator. Anyone says without using a calculator?
Do that.
I heard it was
Arc sine.
ambitious. That would be one possibility. Another possibility is it's okay to use a calculator.
Yeah, it's
And then just figure out which one and you're going to get digits.
Why is possible? Why is that?
Well, what is that matches?
What would that be? The inverse sine of 3 over 2? Oh, 3 over 2.
Oh, I thought you were
Yeah.
okay, so it's 3 over 2 is
What?
Number 2, did you get pi over 3? Does it sound right?
I don't entirely understand, but while Wendy is out, they've divided her tasks in ways, and I still haven't entirely figured out what, I know what my things are, but I don't entirely understand what her things are. You know what I'm saying? I mean, like, the things that aren't me, I don't know which of them are supposed to be.
So
And
he's
so, like,
what?
Like, I put
negative 90 degrees.
which I put,
I guess you could always have
It's literally
So, you know what I'm saying? And like, I don't really understand it. Yeah. And they'll probably sign up your class.
I mean, technically you can teach yourself anything you
Oh.
wanted to.
Okay. What's central? Yeah, just and she'll know exactly where to put it. We just have to have a
Social contract.
Yeah.
until you're out of high school, we have, even if you're
being an adult.
Some
We have to
like
have
some kids like, don't have like
Yeah, can't do
We got to go
11B either.
You know what I'm saying?
You're sick. Can't do 9 or 11.
Actually, you can do 11B, actually.
if somebody really wanted to learn something.
Just go to
There's charts in the
Just these charts, and then look down here.
Yes, you want to find the angle where the first one is a half. Yeah. Right. And
For 11?
for all from an angle of 0 to an angle of pi.
Oh, wait, yeah, never mind. I did it wrong.
There's those charts.
That's not.
Yeah, they're not on there.
Okay, MJ, I'm sorry.
I'm a lot of
We finished it.
Sure. I don't remember. I'm sure
Well, I gave it to you.
it's there. Okay, thank you.
Oh, yeah.
0 probably.
Was there a homework for last class?
Yes.
Well, then let me get them from you.
There's a lot of graphs.
It's a lot of graphs. Yeah, my email's been full of graphs.
It's like 20 graphs.
It's 10 graphs, excuse me.
Did you count?
To make sure I send them all.
Google knows exactly what you
How's it going, Brayden? I hardly ever get over it.
Really good because I just inverted
I'm alright. I miss our abilities over there to find it. It's weird to have you here. You have it, you know. The last one we
That's not progress. So 13A.
Oh yeah, he was like, that's like I've heard of that.
Storehouse is right there. Alright. Aaron's friend.
I don't do that. Okay, so I did this.
Oh, I hate that.
And I got half.
Okay, perfect. Yes, you're right. You did it right. I'm excited.
Because okay, so I was looking on here and I changed it like because it's not the inverse
Yeah.
or whatever, and that's what I did. So,
Yeah.
so okay, cool.
I'm happy. That's cool. You have a homework set? Well, you
Yeah,
yours.
that's
Did you give me a homework set?
I mean, technically,
I'm not missing it. I used to like, Alright, what do we got over here?
You already gave me these You told me here. Oh, what is that?
Okay,
Where all these boxes
Huh?
13 is all 13 boxes.
That's how you feel.
No.
That's right.
That's how you feel, me. We could take the figure from the front of the deck and find the angle whose sine
That sounds original.
Yeah.
that's
I can probably do that.
looks like 25 degrees.
Still sounds.
She's like, okay, so we're gonna meet at 11 right now.
yeah, I mean, we did some movies.
Oh, I told her, I'm like, okay,
So
this
you only see it.
this is when I go to class. Here's where I go to class at 11. I'm like,
Only one that has
we'll have time.
That's great.
Have you got E220?
Okay. So this is
Oh, so what is plugged in?
Yeah. And then you get there, it's not possible.
well, it's either that sine divided by that plus one in there.
Dude, yeah, because radians always has something to do with mine.
You totally can write that in files.
I'm good.
That's my graphs last night.
I have a whole bunch of
Let's switch it up real quick.
Alright,
Yeah, they're completely different. So, it doesn't say,
turn out his homework.
it doesn't give us
Here, what's this?
some measure.
219. I didn't agree.
Don't do it
alright.
every time.
Is that what chapter 4 says?
Doesn't
That's what I
have
figured,
to.
because it already gave us those. Because it's really small.
I swear.
You swear to your face.
Yeah, because the other ones are the radio. You swear
Yeah,
to
it
your
is.
face.
It's in radians.
Because he comes all the time.
It's in radians. Well, it doesn't say rad, but it doesn't say
It's history, man.
I think it's just because
History.
they put them all in like the one form.
It's all
Like on the
All right.
other they're all like square root 2 over 2.
That's not
in
I'm
the
saying
radius.
that I was bad.
And all of these are just like, hey, we're decimal or we're negative 3 over 4, but
Like symphony spurn.
I'm a
still count as
That's not
normal.
like.
So arc sine give me 45 degrees.
All right.
So what would it be?
You are so jealous.
Yeah. That's not what it's right.
Brandon, I love how like you're done with the work that you did do.
Oh, heck, I never
All
stopped the
of
camera.
this. It's like you plug it into a calculator. You didn't exactly do any work.
I did it in a